Emily Robinson is a data science consultant, primarily as an expert witness on trade secret cases. Very, very interesting topic that is in and of itself. Maybe Emily can enlighten us on that a little bit. Previously, she worked at Warby Parker as a senior data scientist, and prior to that, she had roles at DataCamp and Etsy. And Emily is co-author of the excellent book, Build a Career in Data Science, which she co-authored with Jacqueline Knowles. I just got to finish up that book. I started a couple of weeks ago, and then with ODSE West, I got interrupted, but I just finished it up just in time yesterday. So it's an excellent read. I really love the journey she brings the reader on, so do check that out. We will be posting that book link with a discount on our chat channel shortly, and both Emily and Jacqueline have an accompanying podcast, and we'll post a link for that as well. We would encourage you, especially if you're interested in the subject, to check that out. And again, remember, please feel free to add your questions to this conversation. Emily, welcome to the show.
Thank you. I'm very excited to be here.
Great to have you, Emily. I'm really looking forward to this conversation, because I do know a lot of our listeners do have questions around this. But let's start with a few introductory questions. You got a very interesting background, especially your latest gig as a consultant there as an expert witness. So tell us about your journey to becoming a senior data scientist and author, if you will.
So it started in college. So I graduated in 2014, and data science was a thing then, but not nearly as well known as it is now. And what I'd majored in, I actually created my own major called decision science, which was a mix of psychology, economics, and statistics. I then went on to a PhD program at a business school called INSEAD, which is in France and Singapore. I was doing a PhD in organizational behavior. And then my second year, I was kind of like, I don't know that I want to go into academia. And certainly, there are a fair amount of PhDs in industry, but either there are a few PhD programs where like that is sort of known, it's pretty common for people to go into industry, but most PhDs are, even if that may not end up being what people are doing, are kind of designed for you to go into academia, right? And so they emphasize, academic research skill, publishing papers, and that's expected to be what you want to do. And in my case, I was like, I don't think I want to do that anymore. And so I decided to leave my second year after I got my master's to go to a data science boot camp called Metis. This was in 2016 now. And from there, that's when I got, then Etsy, the DataCamp, then Warby Parker, as I talked about. I find that the social science background was quite good for going into data science. It's not an uncommon background, especially I'd done a statistics minor along with my major. And, I found I did some specialization in A/B testing. I at Etsy, I was working on a centralized data science team, but where we were kind of matched with other teams to partner with. I was working with the search team, and it happened that one of the things they really needed was help with running experiments of changing the search page. Do people actually, buy more, register, whatever we want them to do, click more on the results. So I ended up doing a fair amount of A/B testing. It worked pretty well with my background in social sciences, running experiments. Led to DataCamp, where I, built their A/B testing analytics system on the growth team, where we started running experiments there for the first time. And then at Warby, where I kind of went back and did more of a mix of things, some stuff with experimentation, some stuff with machine learning, with computer vision, deep learning, making a model in that way. So I've done, and now, as you said, I'm working as an expert witness. And one of the things I like about that was not something I ever thought would happen, but basically they found me from some of the work I'd done publicly around, especially A/B testing. I'd given some talks on it, some blog posts. And so I've always sort of advocated for doing public work if you can, because it is certainly something that can help with the job search, with building your network, but also because sometimes you don't even know how it will help you. Right. And that was definitely the case here, is I never set out with this intent, but if I hadn't done it, this job never would have happened. And so I do think it's a nice little case study in those unexpected benefits of doing public work.
No, that's an excellent introduction, Emily. We always say that's why we encourage people to speak at our meetup, speak at our conference, send us a blog and we'll share it with the community. And, in the midst of all that, your career, very busy career. We all know writing a book is a very heavy lift. A lot of people we speak to tend to be technical book authors within the space or within the technology space. But I love the fact that you choose to write a book specifically for, helping people with their career in data science. And I think you already just mentioned, it's important to do public work. So what was the inspiration behind writing this book?
Yeah, so I've written some blog posts with career advice. I wrote one on managing the business challenges in data science, and giving your first talk. And often I find my inspiration in these kind of posts. So like, what do I wish I knew 6 months ago, 9 months ago, right? What are things that I've just recently learned and, I think would be useful for other people? I'd done those blog posts, and then I went to, again, unexpected benefits. I spoke at a conference, Data Day Texas, early 2018. I met, some of the other speakers, including Jacqueline Nolis, and then she reached out to me a few months later saying, hey, Manning, this publisher Manning has approached me about writing a book. Would you be interested in co-authoring it? And, Jacqueline had both seen me speak at that conference, but she'd also seen some of my blog posts. She was like, okay, seems like Emily can write, might be interested in this. And we were kind of off to the races and did a book proposal for Manning. I'm trying to remember, I don't remember whether we knew, I think we knew sort of from the beginning, certainly before we wrote the proposal, but I'm trying to remember even before we had the first conversation that it would be about careers. And I think really what inspired that was that there certainly can always be more, but there are a lot of technical books out there, right? Or courses, or, whether they're MOOC or they're platforms like, Code Academy or something. There's just seems to be lots of blog posts, lots and lots of resources for getting started with programming language, or even, I want to do time series analysis, I want to do deep learning, I want to do this. But I found that there were fewer resources and they were more scattered for these things that often felt equally important in starting to work in data science or, doing well in your first job, which are things like, what are the types of data science jobs out there, right? How do they vary between different companies? How can I put my best foot forward in interviews? How do I handle when my data science project fails, and what are the different ways that a project can fail? And, even up to what does it look like to advance in this career? Some people might think, oh, is management the only track, right? I got to eventually become a manager. And actually, no, you can do a bunch of other things. And I found that my background, especially with sort of the social science organizational behavior, I've always been somewhat, career minded. And I'd also learned about concepts like sponsorship, which is different from mentorship in terms of offering opportunities to people rather than advice, and that often can be much more impactful. And so I wanted to, share these back. And Jacqueline was a great co-author for me because, I do think it was a benefit for having entered data science more recently, right? Because even now, we wrote that book in 2020, but I entered in 2016. It is different these days. So it was more recent then, but also I had Jacqueline, who had been a manager, who had been a consulting, right? So I think we also have somewhat different approach to things. So I think we ended up balancing each other out really well. And I do think made it much more enjoyable and easier to write a book with someone else, both because she took on some of the chapters, but also because she would, read my book, and it gave me read my drafts, and it gave me some accountability.
No, that's great. It's very well structured. And as you mentioned, I think there's really learn how to code in 24 hours, how to become a data scientist. Lots of blogs out there, lots of technical books. So I really think this is something that is needed. And we just shared the link to that book with the code. So please check that out when you have a chance. And yeah, so as mentioned, I really like the way you guys laid out the structure of the book, and we get into various chapters in a moment. But top of mind always is one of your earlier chapters goes into recommended methods for getting data science skills. Like people think we always talk about it here. There's different ways of getting data science skills. There's self-learn, YouTube, blogs. You said you're at Metis, which is a great bootcamp program. We run a mini bootcamp program at ODSC as well. the longest one, and I'm a big fan of a 1 or 2 year masters. So there's no one method for all, but tell us some of the recommended methods for getting data science skills, and if you don't mind commenting on which are your favorite methods.
Yeah, so you named a couple, and it does, really depends on your background. So the boot camp was a good fit for me because I had the statistics background. I'd been programming in R, learned it in undergrad, did some in grad school, but I didn't have, I hadn't really used Python much. I was kind of interested in learning that. I hadn't used GitHub. I didn't have a portfolio of any projects that I had done. And I hadn't really done any machine learning either, although as I learned, machine learning sometimes is like, oh, I do know this. It's just called something different, right? I learned this in my statistics class, this like exact same thing, but it's called this. But it still was helpful. There were other things that I hadn't really done at all. But a boot camp's only 12 weeks, right? And they do have an admissions process, which I think is good, because I don't think you'd succeed if you go in having nothing, right? Having maybe no background in math, no background in programming. I do not. I think both the bootcamp would be really hard, and honestly, I think your job search wouldn't be very successful afterwards. So I think it works best for people who have some of the skills, but want to spend some time making a portfolio, and then also maybe filling in some of the gaps that they don't have, right? Which and in a data science and tech career, you'll always be learning more, which you'll continue to work on in the job. So that's what I think sort of boot camps are most useful. And for me, I'll also add, I also benefit, right? You pay for a boot camp, and although it's a lot less than a master's, you're still paying for it and you're not making money. I was able to live at home. My parents lived in New York City. I moved back for that. That also helped a lot. I was coming from grad school where I was getting a stipend, but it wasn't like, oh, I was living so lavishly beforehand, right? It might be, if you're not lavish, it might be harder if you're coming from another career, right? To take 3 months without a salary where you're paying. And then also it would take at least 2 months, and easily longer to get a job after that, right? So almost half a year where you don't have a salary. So that's what I thought on boot camps. Can be a good fit, but works best for people who have most of the background they need. One of my favorite ways, which you mentioned, is learning at the job if you can, right? So what I mean by that is, let's say you're an engineer or you're in marketing at a company, right? Are there ways that you can use data more in your job that you have, right? So I know, and some engineers, even who don't want to switch to data science, find themselves using data more. I don't know, maybe looking at like outages, like page load time, graphing that. What's it? Are there any predictable ways? Learning more about, maybe they're working with a data scientist on running A/B tests, right? Testing out the features they're building, and if they're curious, they might learn more. It's like, hey, what do you mean by power, right? Like, what should we be thinking about? How should we? Why can't we just cut the data all these different ways and say, oh my gosh, if you're this age, you're living in Montana on a Saturday, right? Like, that's where our feature succeeds. What's wrong with that? So I think that can often be a good way, because, then you have the benefit of your domain knowledge as well, right? So, let's say you're working in marketing and, you're learning more about how to use data about your marketing campaigns, but eventually you want to become a data scientist. One of the best ways it can start is as a marketing data scientist, right? Because you already know a lot of the skills you need to know about, like, okay, what do campaigns mean? What are things that are important to the marketing director, right? What are the different measurement tools, right? And maybe you build up those skills to interpret the data, or maybe gather data you couldn't before, but you're starting from a solid foundation. So that's often my recommended way to do it. And then I'll kind of cover, just like as a last bit, self-learning, I think, can work well. It's usually free or like pretty low cost, but it can be challenging, just that accountability piece, right? The self-motivation. I think it's nice if you can find a community, both the accountability, but also just to make it more fun. And I also think it works really well if you apply it. So rather than just taking lots of courses, if you can apply it to a project, or sometimes what I'll do to, if I'm like, oh my God, there are so many things to learn, it's like, okay, well, like a little bit of just-in-time learning, right? It's like, okay, well, what's something that I really want to be able to do? Oh, I want to make a little bit of a web app, to display some data and let people interact with it. Okay, maybe then you learn, Shiny and R to make that web app, right? Rather than just starting from this giant field of all these possible things you can learn. And finally, the masters, I haven't gone down that route. I would say, be a little cautious, think about the money investment, think about, try to find out what are the rates of people getting jobs afterward. How are the courses, are the courses also up to date, right? Like what languages are they using? What techniques are they taking? Because if the professor's been teaching for 20 years, maybe they haven't updated, I know someone taking a Bayesian course and it's using like WinBug or something, like some, Bayesian language that like just no one really in industry uses, fortunately she's able to do it in Python. There's one TA who can like help with the Python stuff, but really there's lots of different ways. And again, I think it really depends on what background you're coming to, right? If you're coming from an undergrad in computer science, you're just graduating, that's quite different from someone who's, a VP in marketing, maybe, and those different trade-offs you want to make, different and different aspirations maybe for your career.
No, that's awesome answer, Emily. And, I really think people underestimate, because a lot of people switching into data science and AI, they are career switchers, right?
Mm-hmm.
And they do have a lot of domain knowledge. Like I was talking to a historian acquaintance who really want to get into data science and AI because they were a historian, but they loved the whole data aspect of it. Was struggling to get a job, and they worked for a very large publisher, which is not a machine learning or data science shop. But I was like, look, everyone has data. There must be some data in there. And they actually started working part-time for the marketing department on some of the data they were collecting, but it was relevant to the publishing, especially around nonfiction. And they were able to do that for a year, kind of as part-time for their role, and then they transitioned into it full-time. So, yeah, and I think people underestimate the value of domain knowledge. Because at the end of the day, you may be working in tech, but a lot of us are working in other industries. It might be finance, healthcare, marketing, retail, and domain knowledge is really a strong part of it. So I think that's excellent advice. And so it's interesting about the self-learning, because, one of the things I've always struggled with, and I know other people struggle with as well, my background was in engineering and then in quant finance. So I had a pretty good code background. I had a pretty good calculus background. I was pretty weak in statistics, never paid attention. So when you think about the data science skill set, which you mentioned in your book, you've got a master of statistics, math, programming, and then, you have all these frameworks to learn. We'll get into it later, but are people, because I wasn't realistic about how much time was going to really get me to a mastery of data science and machine learning. Even though I spend a good chunk of my work still working in machine learning, I tend to be more on the NLP side of things. But are people realistic about the breadth of skills they have to master and how long it's going to take?
Yeah. So actually, I'll push back a little bit on the premise of that question, the mastery. So one of the data scientists I used to work with, I really liked, he said once, as a data scientist, you're all gaps. It's just a question of what you're going to spend your limited human mortality to fill, right? As in, like, you will never master all of data science. Like, it is just a huge field. And there will be some portions where you don't know anything, right? Like, maybe you know almost nothing about time series, but so far it hasn't mattered because you've never worked on a time series problem. So sometimes, or you never use deep learning, or you never do anything with A/B testing, right? Or you never do anything with Python, right? You only work in R. So there's just, but that being said, right, I think there certainly need some foundational skills, and often there's this idea of a T-shaped data scientist. I mean, you sort of have some foundational skills across these things, like statistics, like programming. But then maybe you have a specialty, and that specialty might be a domain of, for example, marketing, or it might be a technique like time series. And I think often that can pay off because you do need those foundations. For example, if you can't, if you can't make a basic graph, or you can't pull data with SQL, you're not going to get very far. Like, there are just some things that you'll use in almost every job, or you don't, you need to know, I often call it like statistical intuition, like, do these numbers like pass the sniff test, right? Like, understanding when should I dive more, for example, like, okay, 48 is 48 out of 100 is, bigger than 4 out of 10, right? Okay, but like, what is that interpreting? Okay, but what's the uncertainty around it, right? How certain can I be of the 4 out of 10? Like, understanding those sorts of things. Or if you have an A/B test run for one day, one of the, usually they're not exactly equal, like A versus B with the conversion rates, but it doesn't mean you should be like, okay, let's call it a day, right? You understand, there's some uncertainty, maybe we need to run it longer. But in terms of the time it takes, I think people could be, maybe what they most get wrong is that they'll never know everything in a sense, right? It's like, oh, I can be like a time series expert. It's like, even let's say like somehow you learn all there is to learn right now. Well, in 2 years, there's going to be new stuff, right? Whether it's new techniques or new programming languages or new books or whatever. So I think what I will say about that is, it will take some time to invest, but also not to hold yourself back and feel like, oh my gosh, I have to know everything before I can start searching for jobs or before I can add value as a data scientist, right? I think there's certainly like, okay, I can take some time. Maybe I already have some of the foundational skills I need. I can fill in some of those gaps. Maybe I figure out, okay, where, based on my background, my T-shape be right now. And then realize you're going to continue learning all the time on the job, right? And that's just like a fact of life of this career. And it can be scary. It can be exciting, but, not feeling that you have to know everything before you can become a data scientist.
Yeah, exactly. I think that's something I learned the hard way, that you continuously have to be learning in tech data science career. I thought once I got out of college, I'm done studying. And unlike my friends in sales and, doing real estate sales and software sales, of course I had to do some learning, but in a STEM field, I think it's the same right across STEM, that's number one. Then, yeah, you had a great comment. You were talking about looking at numbers to pass the smell test. Like, we see a lot of people come to the conference and they start to feel overwhelmed. Like, they go straight from I know nothing about data science to want to know advanced deep learning skills, or advanced machine learning skills. And I think it's a good hack. And it's interesting to me because, not to go off topic here, but data-centric AI has been a thing. I thought data-centric was always a thing because, you can never have good models without good data. But I do love the re-emphasis on data because, to me, if you get some basic statistics under your belt, in my view, like what I'm looking for when I'm hiring, if I'm hiring a junior data scientist or something like that, like most of your job is going to be involved in just, data wrangling, getting your hands involved in data. Like SQL, you're in social science, which is a lot of people use R in that. So I was using R, Java, Python. Programming languages are hard. SQL is super easy to learn. Database is a little more difficult and annoying. But, basic statistics, SQL, you're going to be spending most of your time data wrangling anyway. So that's a great place to start. And, we know from polls, like I always read the Katie Nuggets, the O'Reilly polls, most of the models people still use are, classification, cluster analysis, random forest. They're not going to be working on advanced stable diffusion models day one in the job. So I think, mastering data, as you just mentioned, is a key one there as well. And I'd even go beyond that and just bringing that back together and learning on the job. I encourage people who are struggling in the job markets, I can't get a job as a data scientist, then go get a job as a data wrangler. Go on to Fiverr, Upwork, or TopTal or someplace like that. There's loads of people, we need it all the time, labeling data, classifying data, using your domain knowledge, just helping people wrangle the data, because that's most of the work anyway. So exactly that, because I see a lot of people holding themselves back because they feel like, especially when they self-learn, it's almost like they set out a 2-year master's program. At the end of 2 years self-learning, I'm going to be the equivalent of, like, that's way too long.
Yeah. Or get a full-time job as a data analyst, as a business analyst, right? Like, I think those things are great, and you'll learn a lot of really skills that are very valuable for working in data science.
Okay, so let's assume they're mastering these skills through some of the methods you mentioned. You devoted a whole chapter in your book around building a data science portfolio. A lot of people focus on, hey, resume, cover letter, send it off, I'm done. Why is a portfolio so important?
Yeah. I do want to caveat, I certainly don't think a portfolio is required. I know plenty of successful data scientists who do not have any. So a portfolio might, it could be projects on GitHub. It could be blog posts. It could potentially be talks. And again, I know some very smart, doing very well in the career, and data scientists who don't have that. So it's not a requirement, but I do think it can be very helpful. And why that is I think, it's just more evidence that you can do the job. And that's something that can be very hard to show if you haven't done the job before. But with a portfolio project, so I'll give an example of actually one, sort of taking my own advice. One thing I just did kind of for fun, which is I really like the series on Refinery 29 called Money Diaries, which are, anonymous people submit their weekly spending. So for 1 week, they kind of track their spending. They also submit, their age, their salary, their, housing costs, their monthly costs, as well as like, a little diary about like, oh, I went out to dinner, it cost this much, or like I booked this trip, whatever, right? Sort of peek into people's lives, but there's no search function. So if you're saying, I want to look at diarists who live in New York City, or I want to look at people who make less than $50,000, there's no way to search on Refinery 29 for that. So what I did was I used, I did some web scraping with R. So I went through, I took all of the money diaries. I got their titles. I did some, regular expression to get out information like the age of the people, like what they pay in the monthly housing costs. And then I made a little web app for that with, has one row per diary, and you can search it, you can sort it, and then it allows you to click the link to get the full diary. And, I give that example, like that's the kind of thing I recommend, because what does that show a company? It shows I can gather the data myself, right? I can parse the data. There was some like headaches of like, oh, why is the data structured like this? It's certainly messy. Oh, there are exceptions to the rule, right? Everything I found is not necessarily a money diary. It might be an article about something else. I got to exclude that. What's the most useful way to display this information? And then at the end of the day, make something that's useful to other people. Right. So this app is not just for me, like any, and I was able to, you can publish it for free thanks to RPubs from Posit, and anyone could go on and use this app. And that's the kind of thing I recommend, because again, that shows the company. I also shared my code on GitHub. They're like, oh, hey, this person can do these things that I want, that I'd like. And they're not just going on Kaggle and predicting the, who dies in the Titanic with a clean data set with a very clear problem. They're coming up with an idea themselves and seeing that to the end. And so I think that can be a very useful thing to show, obviously, both the specific skills involved in that, whether that's web scraping or machine learning or whatever, but also, again, that you can do this kind of end-to-end project.
No, I think that's absolutely fantastic advice. All right, Emily, it's time to get ourselves in trouble, because we're going to ask the age-old question. Can't count how many times I've been asked this question. And you mentioned R, you mentioned Python. So people just starting out their career like don't have time to learn R and Python. Mm-hmm. So R versus Python. What's your recommendation?
Yep. So I personally love R. It's where I started from, but I will say Python is more common. So if you just want to like get the broadest access to jobs, I would learn Python. Some places are Python or R. That being said, one caveat is maybe if you want to go into a specific industry, like, I don't know, healthcare or something, or government, like maybe check out there, because there are some domains where R might be much more common, right? Or so first kind of test that assumption, but in general, Python's a more common one. And also my understanding is that can be a little easier for folks who come from programming in other languages to kind of grasp, because it is more like similar to other programming language. R was started as a statistical programming language. What that means is I still think R surpass, and I don't think it's too controversial in like this data manipulation, data wrangling, and in data visualization. So the Python plotting libraries got much better, but most of them will even say they're basically trying to copy ggplot2, which is R's like big plotting like data visualization language. And I'll close with saying though, I'm giving a keynote in a few weeks on integrating Python into our workflow. So there are an increasing number of tools to make it easier to work with both. I still don't think people should learn both when they're starting out. I do think it's better to pick one and like get better at that. But I'm hopeful for the future, it will become very easy to go back and forth between them within one document, passing data back and forth between them, because I think, most people now, each language has their own strengths, right? And so I do hope for sort of the future we can use both. But that being said, I would pick one when you learn, but let's say you try learning Python, you're like, oh my God, I'm just so miserable. But you try learning R and you're like, this is great. Like, I just get it. Then learn R, right? There's still definitely jobs out there. And like, don't, don't let it stop you because you're like, oh my God, I should learn Python, or Python's a real language. So you can definitely succeed with either language.
Yeah, and I got to add my own couple of points here as well, because I think that's excellent advice, and I'd like to follow up on that, because I think what people overlook when in the R versus Python debate, they're talking about syntax, ease of learning, and all that stuff. But I was originally a Java programmer, and then when I got into quant finance, they were all using R, not because R was better than anything else, but there's so many libraries in quant finance, bond market libraries that are already built into R. And what's interesting too is like a lot of these financial models, they use different interpretation of the models themselves. They build the algorithm around the model differently. And we used to run the model in R, run it in Python, run it in something else, and see what was the lowest error score and things like that. So your point about domain is very, very important. I know from people telling me this, R is also very, like if you look at the R packages, is very big in biotech and pharma as well. So if you're going into either of those domains, it's not so much about the syntax and language, it's about leveraging all the work that's gone before you, right? Because that's the main thing about a programming language is like, does it do some of the heavy lifting? And then I would say as a citizen data scientist, I would love R because you can quickly wrangle data, you can do the modeling on it, and then you can quickly visualize it. You're not pulling in these different libraries, worrying about different version control. Well, package version control did drive me crazy in R, so I'll maybe say that would have tried.
I was going to say, I've heard it's true things get deprecated, but I've also heard a big stumbling point for starting with Python is like getting Python working on your computer. Like, oh my God, it's just.
Oh, yeah, on a Mac, forget about it because.
Oh, the installation paths. Yeah.
Yeah.
Oh, at least R, you like download two things. You're like, okay, download R itself, I download RStudio.
Yeah, exactly. So I think that's great advice about, looking at the domain you're interested in. And even if you're looking to go into finance, and a lot of them using Python now, you can give yourself a little bit of an edge. And, I'm a little different. To me, R is kind of like array-based programming. Python is more traditional script-based programming. And learning at least two languages, like being an expert in one and doing something in another one, gives you a better feel of like I don't trust a professional developer who doesn't know at least two languages, because you're a better programmer if you know how different programs do it. Because, like I said, no offense to Wes McKinney, but R was Pandata way before there was Pandata, right? Pandas, right? Not Pandata, Pandas. So so I think that's awesome. So let's go back to the job search a little bit. So a big problem I see a lot of people have is like these what is it, Greenhouse Connect, Greenhorn Connect. A lot of companies are using these application tracking systems, which drives everybody nuts. You submit your resume, you can do a bunch of other stuff. It's all ignored. It goes through, it's AI filtering your machine learning resume, which is kind of ironic first, or maybe just a really badly written rules tracking system. So, our cover letter still important when you're dealing with these ATS systems, which are kind of like spitting out your resume or pushing it up the list.
Yeah, I think it really depends on the size of the company. So certainly smaller companies like startups, I do think really value people who write a tailored cover letter, right? Like they're looking for someone who buys into mission, who knows what the company actually does, and that can really set you apart. And also there are fewer people usually applying for those jobs, right? If you think of like Airbnb, everyone wants go work, or like Fang, like everyone wants to work there, they post something and they're just flooded. Right? Like some startup most people have never heard of, probably doesn't have like thousands of applicants for this data position. And so they actually, might go through and at least skim each resume or cover letter. But yeah, for the bigger one, I don't know. I think sometimes it could still be valuable. Like if you get through the applicant tracking system and they ask for a cover letter, someone still might read that. If there's something that you really want, definitely one tip I've given before is to try to tailor your resume to the words they use in the job description, right? So if they're using, and that can be a way to the keyword, but I wouldn't necessarily over optimize. I think it'd be obvious when resumes are just meant for like an applicant track and they just like stuff it with all these keywords, right? And that when it does get read by a person, they're like, I don't like this resume. So yeah, but all that being said is I wouldn't, I don't advocate just applying for every job you see on LinkedIn, but I also would say, like my co-author Jacqueline recently went through a job search, applied to about 75 jobs. She wasn't tailoring a cover letter for every single job, right? That would have been sort of a waste of time. Write a good base one, maybe tailor it for a few that you really care about. And then, otherwise just kind of make each one, like make your resume, your cover letter kind of as can be. And then, kind of go from there. And also you can sort of tell from the feedback, if you're getting no hiring manager interviews, maybe you need to tweak it more. If you're getting the hiring manager interview, like probably at that point your resume is fine, and maybe then it's more about the interviews for you.
No, great advice. I joked to a friend like a couple of years ago, they were overfitting and definitely keyword stuffing their resume for every job. And basically you're building a Word effect for every job versus your resume. So yeah, it can definitely be overdone. So you cover this in your book, because we have about 10 minutes left. So there's like 3 or 4 key questions I want to cover. Tell us about, you have a chapter on this in your book. Tell us what data science interviewers are looking for in a strong candidate. What are they looking for that makes you a strong candidate, as they say in the industry?
Yeah, I think there are a couple general things. So certainly those foundational technical skills, which like sounds obvious, right? But most interview loops will have like potentially a SQL interview part. Maybe they'll have a take home. Maybe they'll have like a case study there, right? And they need to know that you can do like the basic technical parts of the job. So that's kind of one maybe obvious one. The other part I think is that you care about the business outcomes, right? That you are not just doing it as like, oh, that they're worried you're going to disappear into a rabbit hole because you want to learn this deep learning thing, or you're going to apply machine learning somewhere which really just needed, like a dashboard or whatever because you want to learn machine learning or you think it's cool, right? Like they want people who care about what the business is doing, who care that their work ends up providing value and not just that it was like really fun and cool work to do. And so to get to that, like you often have behavioral interview questions, right? Because they also care that you're good to work with, that you're someone who can handle conflict, who will, be a pleasant colleague, who will get their work done on time, things that are important in any job. So those are all general things, but then it also really does depend on the job, right? Some companies, maybe you're being hired, like say I was at DataCamp to like build their A/B testing analytics system. Like that's a pretty specific set of like technical skills and, maybe some self-starting ability. Versus another job might be like, oh, we're more kind of general like data analysis type things. We kind of help out across the business. And so it's more, we're really looking for someone who can very quickly get up to speed on a new domain and, provide some value and do some reporting or dashboarding or whatnot. So I think definitely pay attention to what the job has. But the last thing I will say is we said this in our book, I think, which is job descriptions are often wish lists. And so not to feel that you have to have everything, but I think I knew that, but it was really driven home when I was on a hiring panel once, not for data science, for an engineering. And like the job description had like at least like 2 years of work experience and experience in a specific language. And the person we ended up hiring had neither of those, was a college grad who had not worked in that language. And, I think they still did a good job, whatnot, but that really drove home to me like, wow. But also, and it's also a problem though, because sometimes those people who aren't applying, who are opting out, might be folks who are traditionally underrepresented in data science, right? It might be women or people of color, this kind of gap. So I will say that last bit of, again, it's both, don't feel like you have to know all the data science skills to be a data science, but also to even apply to this one job, right? Take it with a grain of salt. If you have none of them, that's probably a red flag. But, if you're like, hey, I feel like I could do this work, I have 60%, 70% of the skills they're asking for, you might end up being a very good fit.
And so let's say you get great advice again. Let's say you get through all this. Now you get the job offer, which again, I think you cover in your book. What are some tips on negotiating a good offer?
Yeah. So I think the first is just even that you can, right? Like some people don't even try to negotiate. They're like, oh my gosh, I just need to like get a job. And so they'll just sort of, they get that call, they have an offer, they'll just be like, I accept, right? So I think first, like take a pause, usually say like, definitely express excitement, they're like, oh, it's great news. I'm, really excited to hear, I'll need a few days to kind of look over the offer. right? So buy yourself a little time. Also, you might, maybe for you, you really care about the healthcare benefits, right? Like maybe you have a family or you have a child with special needs, like that's something that really matters to you, or you just like want good healthcare. You can absolutely ask, like, usually they should send you some of the benefit information, but if you need something more specific, you can ask for that, right? Because maybe and that might be something that's tough to negotiate, right? If it's a bigger company, usually their healthcare plans are what their healthcare plans are, but maybe you can use that as leverage of, say, like, their healthcare plan isn't as good. You'd be like, hey, I'm coming from a place where I had a really good healthcare plan. Like, this is a high deductible plan, like I am losing, maybe your salary wasn't more than they're offering, but your benefits were better. You used to have a 401k match, you used to have that, right? Like, what are those points of leverage that you can have to negotiate for, maybe a better salary or a signing bonus? And I would say, like, usually there's almost always some room to negotiate, like at least a couple $1,000 or, like a couple percentage points. But the way I've seen people get really big jumps in their offers is through having a competing offer. I think it's quite hard to get like a big jump. And I've seen people get, tens of thousands of dollars, 10, 15, 20, 30% more because they have a competing offer. Like, this place offered this amount. And you're like, this company, I'm really excited about your company, but like, this place is offering me 30% more. What can we do to get closer to that? Maybe sometimes they can't, but maybe they can, and know that you have leverage, right? Like, you presumably want this job, but they want you too, right? Going through the hiring process is expensive. It's time consuming, especially if it's more niche job. There may not be that many people that they found that's a good fit. And so when they found you, when they're excited about you, like, that's where you have a lot of leverage. And so, there's tons of good negotiating advice out there, right? Both for job offers more generally, like, definitely look that up. But just remember, like, you should be negotiating, and you don't want to leave opportunity on the table.
No, absolutely not. And it just amazed me. You said the key word there, that you can actually negotiate.
Yes.
I've never heard of anybody saying, yeah, I asked for slightly higher and they said, sorry, we don't want to talk to you again.
Right. And that's a huge red flag if they do, right? If you do it politely, if you're reasonable and they're like, nope, we're yanking the offer, like, you don't want to work there anyway. That's a really bad sign.
And as a consultant myself, I've also worked on some HR software over the years. And I do know for a fact that a lot of these platforms have what we call a low, mid, and high range. Yeah. And no HR person ever picks the high range.
Right. So they
always start at low. Right. Exactly. So they have some leeway, and they almost expect you to negotiate a bit.
Right.
So I don't want to give away too many trade secrets there, but you can definitely negotiate. All right. So you've got us along getting the job, we negotiated the offer. Now we're in the job. So, but again, it's a career, not a job. So how do you, like, any advice for getting to the next level from, say, a junior level to getting to the next level, a senior data scientist or a manager or some other role?
Yeah. So for getting to like the immediate next level, like, which might be like data scientist 2, or it's a couple of senior data scientists, like, it's not automatic exactly, but most places there, like, it's a little bit, it's not quite the start, but it's a little bit of an up or out, as in, like, if you're there for a few years and you don't get any promotion, like, you're probably having other problems. Like, they're telling you you're not doing what's expected for you. Like, most places expect to kind of advance you along to a certain point. And so then I would like listen to the feedback. So I'm not sure, I think we just do sort of the normal things, right? Like, make sure your manager's happy, right? You're presumably, and usually at that point, it's honestly not too hard to get better because there's so much to learn, right? Like, there's so much learning that happens the first couple of years, technical and just working with stakeholders. And so it's really just, be listening to the feedback you're getting, and you should just sort of like start advancing a little bit. That being said, senior is often called it's like a terminal level, as in, like, the next step, which might be called staff or principal or whatnot, is not like a almost automatic step. And you could stay a senior forever, and that's not necessarily a bad thing, right? It's not seen as like, oh, you're a bad data scientist if you haven't advanced, because the staff plus level, like, those start to be a different job. They start to be much more about like leadership, about, having meetings, about like strategy, for mentoring, versus kind of like the hands-on like coding, right? Day in and day out. And so some people don't want that. They don't want that stress, and it also becomes hard to like promote there. Like, usually there's also only a certain amount of spots at most companies for that, right? Because there's not an infinite amount of that type of work, right? Of this kind of like technical leadership work. So that's one path. The other path is as to becoming a manager. I think that I would say what I've heard the advice, I think it's really true, is to get at least a good 5, 6, 7 years working as a data scientist if you can before becoming a manager, because you want to have that really solid, like technical base, that breadth of experience before going into management. But you certainly don't have to. Like many people never go into management. If you want to go into management, you can also come back to being role there's I've heard but because it is almost a different job, right? There are a lot of different skills. Obviously your skills that you built as a data scientist, there's some overlap, again, both technical and and also just working with stakeholders, but there's a lot of new things that you've never had to deal with, like hiring, promotion, dealing with poor performer, figuring out like getting projects for your team, right? Like talking to the higher ups, all these things. And so you should plan to at least devote about 2 years to that if you want to try it, because it's going to take time. It's going to be challenging. A lot of people find it quite draining if they have a lot of meetings. It doesn't have the immediate feedback of coding, right? Where you're like, oh, I push change and I see it, right? If you're coaching someone, it might take 6 months for really to see the benefits of that. So I'd say there's different paths, but I wouldn't, if you're just starting out, I wouldn't worry. Like you've got lots of time, right? It's like, I wouldn't worry. I'd worry about doing a good job in the role that you have. Again, paying attention to feedback, and then sort of like tackling that when it comes to it, but also not feeling like you're choosing for life, right? All of these things. There's a great blog post by Charity Majors, like engineering management, like the pendulum, about like some of the best principal, engineers or data scientists, and some of the best managers are those who have spent time in the other track, because they can bring those skills back to their the other one.
Emily, fantastic advice as always. So I think we're out of time, but so much great insights, so much great advice. Really, thank you for being on the show. I learned a lot. I'm sure our audience did as well. And again, I would encourage people to check out Emily's book, check out the podcast. We've a webpage link as well. And Emily, anything coming up that you want to make people aware of? You mentioned we're speaking at a conference in the near future.
Yeah, that's going to be in Spain, actually, which I'm excited
awesome.
about. Yep. So I was heading out there in 2 weeks. Right. So like right now I'm doing some consulting. So if anyone wants to talk to me about that, you can reach out to me on LinkedIn or, who knows what's happening with Twitter, but I'm still on Twitter as of now, like Robinson_ES. I'm happy to connect and chat with folks. And thank you again for having me on. It's always really fun to do these.
Yeah, we'll have to bring you to ODSC East or one of our other conferences we have coming up, because this has been super insightful and super valuable. So Emily, thanks again. We'll chat later.
Thank you. Bye.
Bye now.